Hi, and welcome to my tutorials on Euclid's Elements. If you are not familiar with who Euclid is, he was a mathematician from around 300 BC. Although Euclid did not necessarily derive new geometric properties, he was the first mathematician to derive these properties from basic principles, his 5 postulates, or axioms. So why would you want to study Euclid? Well, because it's fun. It kind of can be compared to logic games and has simple rules, but it also has the side effect of teaching one how to think logically, not just in geometry, but science in general. And to quote Albert Einstein, if Euclid did not kindle your youthful enthusiasm, you were not born to be a scientific thinker. So what is the goal of these tutorials? Well, the goal is to derive the geometric principles from 5 basic rules, or Euclid's postulates, using only 2 tools, a straight edge and a ruler. So for example, if you all remember this from high school geometry, we're going to prove that the area of the triangle is equal to 1/2 the base times the height. Instead of just saying that it is true, we will prove that it is true. So what tools are you allowed to use? Well, you're allowed to use a straight edge, which means you can draw a straight line. You can't measure the straight line, you can only draw a straight line. And you're allowed to use a compass, which gives you the capacity to draw a circle. And that's it. Those are the only tools that you can use. So what were Euclid's postulates or axioms? Well, the first one is that it is possible to draw a straight line from any point to any point. The second one is that if you have a straight line, it is possible to extend this straight line in either direction for as long as you want to or need to, even to infinity. The third postulate is that it is possible to draw a circle given any center and a radius, or any center and a radius. The fourth postulate states that any right angle is equal to any other right angle, or that all right angles are equal. And finally, the fifth postulate, the most famous of them all because it's kind of wordy and it's not as simple as the previous 4. If we have 2 straight lines and a third crossing them, if the sum of the angles, interior angles, on one side of the line is less than 180 degrees, if you extend the other 2 lines, at some point they will cross each other. And it is impossible to prove the fifth postulate by any combination of the first 4 postulates or any derivations that come solely from the first 4 postulates. And that's why the fifth postulate is famous. Also, without the fifth postulate, you can develop non-Euclidean geometry, which works in hyperbolic space, or spheres, or things like that. So what are the common notions? Well, common notions are not the same thing as postulates in that they are what was then accepted mathematical truths independent of geometry. So they were, or are, things that are equal to the same thing are also equal to one another. If equals be added to equals, the wholes are equal. So if A equals B, then A plus C equals B plus C. If equals be subtracted from equals, the remainders are equal. So that's kind of the same as number 2. Things which coincide with one another equal one another. So if you lay 2 things on top of each other, if they line up perfectly, they are the same. And finally, the whole is greater than the part. So, with our postulates and common notions, a straight edge and a ruler, it is possible to derive Pythagoras' theorem, a squared plus b squared equals c squared, for a right-angled triangle. To be fair, Pythagoras derived his proof before Euclid, but Euclid is the first to derive it from basic principles. and this proof comes about as proposition 47. So, these tutorials will work through each of the propositions or proofs in Book 1 of Euclid's Elements. And that concludes this video presentation. To see the next presentation, just click the Next button.